Okay, now we're going to be talking about some reaction stoichiometry. This first part we're going to be considering converting from moles of one substance to moles of another. The important key piece of information that you need to know is that you need a correctly written and balanced chemical equation to start with. So let's look at this word equation. Potassium chlorate decomposes to produce potassium chloride and oxygen. Now, like I've said many times, if you don't exactly know the formula for potassium chlorate, the first thing that you should do is say, all right, I know potassium is K plus 1, that chlorate is ClO3 minus 1. Look at the two charges, it's plus 1 and minus 1, and we know that the formula is going to be KClO3. Decomposes is an arrow. To produce, also part of an arrow. Potassium chloride, we should know that that is KCl, and oxygen, so plus diatomic oxygen. The next thing that we want to do is balance this. So I have 3 oxygens on the reactant side. I have 2 oxygens on the product side. I need them to be the same number of oxygens. I know that the lowest number that both the 3 and the 2 will divide into is 6, so I'm going to put a 2 here, and 2 times 3 will give me 6. I'm going to put a 3 right here. 3 times 2 will give me 6. And then finally the oxygens are balanced. Then I have to consider now that I have 2 potassiums, so I need 2 potassium over here, 2 chlorine, and the whole thing is balanced. Finally, once I get my correctly written and balanced chemical equation, I can go on and look at my word equation down here that relates to the chemical equation. What is the total number of moles of potassium chlorate needed to produce 6 moles of diatomic oxygen? Just like you saw in Regents Chem, we're always going to start with our given. So our given here is 6 moles of diatomic oxygen, multiplication sign and a line. Whatever I start with is going to go on the bottom, moles of oxygen. Whatever I need is going to go on the top, which is moles of potassium chlorate. So moles KClO3. Now the question is, what do we do next? We're not looking for a mass here because we're doing a mole-to-mole problem. So I get the number that goes in front by looking at the coefficients from the balanced equation, which is why having this written correctly is so important. The coefficient in front of the KClO3 is 2, so 2 moles of KClO3. The coefficient in front of the O2 is 3, so 3 here. Do I have this set up correctly? Moles of O2 cancels moles of O2, so 6 times 2 divided by 3 will give me 4 moles of KClO3. And this is an example of a mole-to-mole problem. Let's try another one. Given the reaction, nitrogen reacts with hydrogen to produce ammonia. We know that the nitrogen is going to be represented as N2. Reacts with is a plus sign. Hydrogen will be represented by diatomic hydrogen. To produce is my arrow. And ammonia is just a compound that you need to know, which is NH3. Again, like we saw with the oxygens in the previous example, I have 2 hydrogens here, I have 3 hydrogens here. I need a number that both the 2 and the 3 can divide into easily. That's going to be 6. So this is going to be 3 here, so 3 times 2 gives me 6. It's going to be a 2 here, 2 times 3 will give me 6. And by doing that, it also balances my nitrogens on each side of the equation. What is the total number of moles of NH3 produced when 10 moles of H2 reacts completely with N2? So there's 2 pieces of information that we have here. They're looking for the total number of moles of ammonia produced, and we're given 10 moles of H2 to start with. An important thing to realize here is that the decimal here is on purpose, because at the end we're looking for an answer with 2 significant figures, because we're starting with this 10, which is shown as 2 significant figures. So I'm going to write my given first. 10, put the decimal in there, moles of H2, multiplication sign and a line, moles of H2 is going to go on the bottom. I want moles of NH3. And again, I'm going to look at the coefficients in front of the NH3, which is a 2, in front of the H2, which is a 3. I know I have this set up correctly because moles of H2 cancels moles of H2. I'm left with moles of NH3, which is what I want. So 10 times 2 divided by 3, which will be 6.7 moles of NH3 when done to the proper number of significant figures. So here I started with 2 significant figures. I want to end with 2 significant figures. And this middle component right here, we don't worry about that because those are considered exact numbers.